Hello everyone, this is Ambuj Dixit and today I am going to do experiment number 10 in networking lab. So experiment number 10 asks me to analyze packets using a tool called Wireshark, and this tool helps me to analyze whatever packets has been sent from my system to the network or from the network to my system so that I can acknowledge any unknown activity in my system, or I can know about the network connections I have. So the first question in this exercise asked me to examine the frame for the first DNS packet sent by the client. So this is the this is the Wireshark tool, in which this is the after getting connection, this is what has happened from sequence 1 till whatever it is. So the question asked me to examine the first frame for the first DNS. So we'll search for the first DNS. So on the 16th one we have the first DNS. So this is the first DNS. As you can see, there are frames, Ethernet, IP, user datagram protocol, and domain name system query. These are the details available with this first DNS packet. Now I have to identify the MAC and IP address of the client. So this will be the MAC address, as you can see in the screenshot, Ethernet 2, and this will be the MAC address. So this will be the MAC address and the IP address given over here. This is the IP address. So what is the content of the type field in the Ethernet frame? So in the Ethernet frame, as you can get inside, you can see the destination IP address, source IP address, and the type of the connection, that is IPv4. So the next question goes like, I have to examine the IP header for the first DNS packet sent by the client. So this is the IP header of the first DNS client, in which in this IP header, all the fields in the header format will be filled out. That is the total length, that is the header length, that is your identification, flags, fragments, protocols, and so on so forth. Now this is the analysis done for the IP header format. Now the second question goes, I have to identify the protocol type field, what is the number and type of protocols in the payload. So to find the payload, I have to go into the IP address for Internet Protocol version 4. So the payload length is 52, that is total length minus the header length, that is your 32. To check that, you can go inside the UDP and you can check that the payload length is 32. So now I have to check what is the number and the type of protocols in the payload, and I have to identify the protocol type field. So first of all, I have to check the frame numbers. So I can go in this and I can find out the frame numbers. Frame numbers are 16. In this it is 215, but in my network connection it was 16. So after that, I have to the next question goes like, I have to examine the UDP headers of the first DNS packet sent by the client. So the UDP header of the first DNS. So first DNS packet is this. Now the UDP header goes like this. In this UDP header, I have the source port, the destination port, the length, the checksum, and the stream index. The destination port 53 is the well-known port number. Source port number is my system's port number, that is above 1024. That is not a well-known port number. Length is the total length minus payload length, that is total length minus header length, that is the payload length. Checksum, it will tell me about the errors in the bits. So this, as you can check, UDP length is equals to total length minus header length, which I showed you already. Now comes I have to examine the DNS query message in the DNS packet sent by the client. So this is the query message. As you can see, this is the DNS query. Inside this, I have so many other options like flags, questions, answers, authority, additional RS. Inside the query, I have type, class, type is A and the class is IN. So this is what it goes. Query transaction, I already showed you. This is the query transaction. This is the query transaction ID 0x1347. Now what is the information carried by the body of the query? I already showed you. These are the um, transaction ID, the flags, questions, answers, authority, and additional. These are the fields that a query tells us about. Now comes the fifth question. Consider the packet that carries the DNS response to the above query. What should be okay? Now comes the packet that carries the DNS response. So first, as you see, my source address was 10.2.3.160 and the destination IP address was 192.168.0.111. Now, this is the query sent. To check my response DNS query, I have to go down a bit. When I go down a bit, I can see whatever the destination address was there, that will become the source address. So this is the response DNS query. In this response DNS query, you have again the headers, frame, Ethernet, Internet Protocol version 4, UDP, and the domain names. So the question asked me to select the packet. I already selected. What should be the Ethernet and IP address for this packet? It should be this one, 98:6C6 colon 0D, and I have to give my this is IPv6 address, and um, yeah, and this will be the source IP address of my system. So what is the size of the IP packet of the UDP datagram that carries the response? So I have to go inside, and the size will be, total length will be 180. So as you can see, this is the size. Now comes the question 6. I have to identify the frames that carries the first TCP segment in the three-way handshake that sets up the connection between the HTTP client and server. So to show the three-way handshake, I can choose any TCP connection. So this is the TCP connection. As you can see, the first TCP connection gives the acknowledgement, then it gives sync, then gives sync. So actually the first will give the sync bit, after that sync acknowledge, and after that acknowledge. So you can see these three are the three-way handshake, as you can see. So these three-way handshake you could observe. Now comes the next question. Inside this question, what is the length of the TCP segment? So I can go to the TCP link, and I can check what is the length of the TCP segment. So inside this, I can check the length is 52. This is the length of the TCP segment. So the third part of this question is, what is the initial sequence number of the segment from the client to the server? What is the initial window size? As you can see, everything is available here. This is the IP header format. So you can see this, the flags is this. This is the sequence number. Sequence number goes here. Oh, okay. Sequence number will be your 0, relative sequence number, acknowledgement number, and here it's not there. So sorry, it's destination is there, source is there. Yeah. So next comes your hex characters that contains sync flag bit. In this, we have flagged as 0x00 sync. Now the next question is, I have to identify the frame that carries the second segment in the three-way handshake. I have to identify the frame that carries the second segment in the three-way handshake. So first segment becomes the sync bit. Second one goes, as you can see here, second one gives the sync and acknowledgement. So this will be the one which will give me. This is the packet which has been asked in the question. So the question, as stated before, asks me to identify the frame that carries the second segment in the three-way handshake. So first segment will always be a sync segment, and the second one will be sync acknowledge, and the next one will always be an acknowledgement frame. So how much time lapse between the capture of the first and second segment? So time lapse can be seen in this. So time lapse is time dealt from previous capture frame, as you can just see from here, from the screenshots. So time dealt from previous capture frame is 1.016, and time dealt from previous display is 1.016 again. So before examining the capture packet, specify the value of the following field, and these are the source, destination. So you can see over here in this thing, you can get the source, the destination, the source GEOIP, and so on and so forth. So the acknowledgement number in TCP, that is sequence number. So sequence number can be traced over here. Uh, uh, sequence number is, for this screenshot it's 118 relative sequence number. So what is the length of the TCP segment? So the total length is 52 for this TCP segment over here. Total length is 52. Now comes the next question. Identify the frame that carries the HTTP GET message. So if you can find HTTP GET message over here, you can see this is the HTTP message. This is the HTTP GET message. So I have to examine the flag bits in the TCP header. Can you explain why the two flag bits are set? Okay, so let us go into the TCP. So in this I have flags. So window size is given. It is flags is header length is 12 bytes. Yeah. I have to calculate this window size and window scaling factor. Now goes the payload length. So payload length can be calculated from the total length, as you can see in IP address, the total length minus the header length. So the header length is 20, 403 minus 20. So you can get it over here, that is 363. So that is the TCP segment length. So the next question asked will be, I have to use Wireshark to capture the ping protocol and examine the series of ICMP packets. So okay, so for that I'll start with Wireshark, and I will stop everything. Now it is asking me to ping and to check the protocols. So I'll use this command prompt, and I'll use this ping command, and I'll ping Google. Before pinging, I'll restart without saving. So I just ping. This is the reply which I have been getting from ping. So as you can see, I have a collection of DNS and ICMP packets, which are the echoes of the ping in the Wireshark tool. So my question asks me to capture the ping protocol, and I have done that, and examine the series of ICMP packets. So I can see the first will be the DNS query, and the next will be the ICMP packet, and it continues with the echo. So reply and the request and reply series continues. So now I have to the next question is, now I have to examine the ICMP message. What is the ICMP message type? So I'll go and check into the ICMP message, and I have to give the internet control message protocol. So I can go inside and see. So this is the uh, these are the uh, things which are there in ICMP version 4. So what are the source and the destination IP address in the IP packet that carries the first ICMP echo reply? So this is the first ICMP echo reply. In this I can see, okay, this is the first reply. So what is the question over here? What are the source and the destination addresses in the IP packet that carries the first ICMP echo reply? So you can see it over here. Source source is 216.58.196.100, and the destination is 192.168.43.253. So this is the source and the destination. Now I have to examine the ICMP reply message. And what is the ICMP message type? Compare the message identifiers and the sequence number in the reply message with the corresponding numbers in the sequence message. So as you can see in this screenshot as well, with the type, the codes, the checksum, and the identifiers. Now I have to use uh, traceroute command in the Wireshark tool to examine the ICMP packet. So again, I'll stop everything. I'll start afresh. Before that, I'll give traceroute command. Now, before start giving this command, I'll restart this, and as you see, this traceroute command starts getting the root of this um, IP address. Here you can see I'm getting the DNS and HTTP standard queries of this time to live exceeded and so on and so forth, ICMP and DNS queries because of that traceroute command. So the question goes like, I have to determine the destination IP address and the IP that carries the first ICMP echo request. So the first ICMP echo is this, and I have to find the source and the destination. So the source will be 192.168.43.253 and the destination will be 216.58.197.68. So this will be the source and the destination. Now I have to examine the ICMP message. What is the ICMP message type and what are the message identifier and sequence numbers? So as you can see in this, I can show you in the screenshot as well. So I have to examine the ICMP message and what is the message type. It is the ICMP timed echo reply, and I have to identify the identifiers and the sequence number. So as you can see in here, I can check that in this identifiers BE1 and BENLE are the two identifiers, and we got the sequence number as well. So how many data bytes can be carried in the request message? That is, I can get inside this, and you can see the data length is 64. So what are the source and the destination address in the IP packet that carries ICMP time exceeded messages? So as you can see, you can get here the source and the destination, the source and the destination. Now I have to list the sequence of the source IP address in the packet that carries ICMP time exceeded message. So you can see this time exceeded message are carried by these ICMP message packets that are highlighted over here. So thank you for watching.